Can you see me on the camera?
Yep. I can see
Okay.
it just fine.
I have
All
my
right,
phone
we're on.
up, so.
Yeah. Okay, this is our 9th meeting, lesson 10. Gonna do the group meeting quiz. Julia can't be here because she's working tonight. Russell, were you able to do the individual prep?
I read through part of the lesson. I didn't finish.
Okay. So for question 3, we got to find the margin of error for 90%. So if you type into the normal probability applet 0.9 and highlight the middle only, we get 1.645, or actually negative 1.645 for the negative 1.645. Standard deviation over the square root of n to find n, or m, excuse me. So if we just plug in the numbers, is it? Because when we did the prep, it was negative. Nope, I'm lying. Wait, nope, no, I'm not. Number 11 in the individual prep, it used the negative z-score for it. I don't know really why though. I don't remember. I think it's the same, because even if it was positive, you'd still do plus and minus. So I think it would still be the same answer. 1.645 times 50 over the square root of 25. Cool. Let me know what you guys get. I got negative 16.45. But, well, I don't remember why. Let me see. Wait. 5A 7 5A says record the positive z-score below. Record the positive. So why did it want us to use negative, like in the reading? For which one? I got, well, I used negative 1.645 as the z-score and got 533.56 and 548.44. Right.
did Russell get?
What did you get, Russell?
Yeah, I'm confused at where to start.
So for number 3, in the reading, we learned that the margin of error, or M, is equal to the z-score of the percent that we're looking for. And so since we're looking for 90% confidence interval, you put 0.9 in the normal probability app for the area. And then you get the z-score.
0.6319.
0.63. Oh, you have to shade the middle
Right.
only. So it
Right.
should come out to 1.645.
So in the z-score, you put 0.9, right? Because we're looking
No,
for
no,
a
no.
nine.
In the area, put 0.9.
Oh, okay.
Yeah. So if you put 0.9, the z-score comes out to about 1.645.
Yeah.
And what we were concerned about was in the individual prep, there was one of the questions that had us do something very similar. And the answer turned out to be the same, whether you used the negative or the positive z-score. And so we were not knowing which one was correct, because to find M, if you use positive 1.645 or negative 1.645, they come out to different answers. And so that's why we were questioning which one it would be. Because then you just plug it into the equation. So 1.645 times standard deviation over the sample, or the square root of the sample, excuse me. And they give us the standard deviation and the sample size.
Right.
So if you plug that in, it's just you get either a negative or a positive, depending on which. If you use negative or positive for the z-score, 16.45.
Right. So isn't margin of error always positive?
I would think so.
If it's negative, it's still positive. Because it's supposed to be an integer, it's supposed to be a positive number constantly. I think it's positive, but
Isn't the margin of error always supposed to be positive? That's what Russell's asking.
I think so.
I thought it was supposed to be,
Because
because it's kind of like a measurement from the distance.
think about it how it is in the probability of it.
Patient.
You want to find like 90% of it. So if you did negative 1.645, that would be like 5%. It wouldn't be 90%. So that's why I chose to be a positive. Because it includes everything that's in here to this point.
Right.
But if you only use this one, it's including everything to the left, which doesn't. We don't even want that. Or to we want what's in between. So you have
Okay.
to choose. I don't
So
know.
we'll go with positive 16.450.
Everything-
If it's not right, then we'll go back. So which of the following statements is true? X is a point estimator of mu. I think that's the right one. Because X is the same as the mean, according to the reading.
What's
And then that's the point that we use to how much.
you were cutting out? What were you saying?
We were saying the second one, X is the point estimator of the mean, because in the reading
Yeah.
they are the same. And so you use your point estimator as like the values, X. That's kind of what we were
Right.
saying.
Yeah.
Okay. Question 5. So what's the point estimate? It would be 526. Right. That's what we're basing it on, is X. So cool. So for this one, in the reading, it said technically if you put 0.95 into their normal probability applet for the area and then shade the middle, it would get 1.96 instead of a flat 2. Because usually it's like, oh, 95, it's 2 standard deviations away from the
You have to put it
value.
in the
But if you put it into the applet, you get 1.96. So let's use that instead of 2. Does that make sense? Probably just made it sound way more confusing, but essentially what I'm saying is m equals 1.96 times the standard deviation divided by the square root of n. That's all I'm saying. Instead of 2 times it, it's 1.96.
Right.
$1.96 times.
No, I don't want to open my email.
Square root of 113 divided by the square root of 64. I got 27.685. Let me know what you get, Russell.
Yeah,
You got the same?
I got 27.685.
Yep, that's what we got. Sweet. What is the lower limit of this confidence interval? Lower limit. I don't remember. What does that mean, the lower
plug it
limit?
into the equation, like the mean minus, and then the mean plus.
That's all it's asking. So it's just asking for the lower one because it's that. So it's the mean, or x minus the 1.96 times 113 over square root of 64. Yeah.
And then the upper.
Yeah. So one you just subtract it and the other you just add it. So 526. Minus 1.96 times 113 over the square root of 64. I got 498.315 for the lower. Yeah. And for the upper, I get 553.685.
Yep.
Yep. Okay, we're all on the same page.
Oh, question 5, the estimate for the true GMAT, that's 0.95.
Right. For question 5, you plug that in to the area for you put as the area 0.95, and then you do the z-score. So point estimate is equal to the z-score.
Okay, gotcha.
I'm sorry. I'm throwing you off.
It's the area.
Excuse me. X is equal to the point estimate. So it's 526 is the answer for 5.
Okay, gotcha.
But to find the z-score, which is what you use to plug into the equation. Then you plug in 0.95 to the area and then find the z-score when you shade the middle.
Okay. It would decrease, wouldn't it?
What will happen to the width of the confidence interval of G? Well, in the I wrote it down in the notes. For this is a 95% one. As the margin of error gets smaller, the level of confidence gets larger. Yeah. So if the sample size goes up, that would decrease the margin of error, meaning that the level of confidence would increase. What would happen to the width of the confidence interval if you increase the sample size? Because if we do an example, just let's say 1.96, same thing, 113 divided by the square root of 64, that gets us 27.685. But if we do that again and we make the sample size like 100, or wait, yeah, if we make that like 100, then it would go down. The margin of error, that is. So if you increase the sample size, the margin of error goes down, meaning that the confidence interval is going to get larger. So it'll increase. Does that make sense?
Yeah.
What would happen to the width of the confidence interval if it was 99%? Well, if we do 99, the z-score is 2.576. I'm trying an example again with that one. So 36.386. And if we plug in a higher number, it decreases the margin of error. So the confidence interval no, but that was a sample size. Hold on. What happened to the width? The confidence interval of Gina changed it to 99% confidence interval. Well, the margin of error would increase for sure because you have a larger z-score.
And then you multiply that by the number is bigger than
So the confidence interval
what happened to the confidence interval of the confidence level were increased say from 95 to 90. Increasing the confidence level will lead to larger values of C.
right.
If C is increased in the margin of error,
Right.
will lead to a wider confidence.
So increase again. So they're both increasing.
Oh, there's another one. What would happen to the confidence interval of the sample size? n was increased, but the other values were still. Since the sample size n is the denominator, if n is increased, square root of n would increase, and the fraction standard deviation of the square root of n which would lead to a smaller margin of error. In other words, if the sample size is increased, the width of the confidence interval will decrease.
So question 9 is decrease.
It will become this is 4.2.
4.2 in the reading. Okay. So
What are you
question
saying?
9. So for question 9, if the sample goes up, then the margin of error is going to go down, meaning that the width of the confidence interval will also decrease because
Right.
it'll be a
I
smaller
figured
z-score.
that because the sample size is on the denominator, and as the denominator gets larger, then the product of it all will get smaller. And so I
Right.
figured it was decreasing.
Yes, yes. So that was my bad. You are correct. But question 10 is still increasing
Right.
because the z-score is bigger, meaning it's going to be a bigger margin of error.
Right.
Okay, question 11. So looks like we just got to solve for n. I got 15.68. Hold on, let me see if I did my math right. So 1.96 times 400 divided by 50. And then that's what I missed, squared. N equals 245.862. Or 246. How what you got, Russell? You're not in the call. I don't see you. Here, I invited you again. Yeah, I'd say you left the group chat at one point.
Okay.
So what did you end up getting for 11, Russell?
I got something completely different, but I may have done it wrong.
What? How are you doing it?
So I was doing it by taking the area from the probability applet because they give us the confidence interval that they want,
Right.
95. Oh wait, no, but that's the margin of error that you would use the applet for.
No, you were on the right track. So if you plug in 0.95 into the area in the applet, you should
Well,
get
yeah, then you
the
get
z-score.
1.96 again.
Right. That's your
Right.
z-score, and then all you got to do is solve for n because they give you the margin
Right.
of error.
You already get the 400 for the
for the standard deviation.
And so I was just solving it like that, like 96 times 400 over x, or the square root of x.
It
I
should
was
be the
solving,
square root of n.
well, square root of n, but yeah, I just used x as a variable. But
Oh, okay. And that's all equal to 50 because they gave us the margin of error. And then just solve for n.
well, 196.
There you are.
It's weird.
I got 14.28. I could be wrong. I'm pretty sure I did
Yeah.
that wrong.
So the equation should look like m is equal to 1.96 times the standard deviation over the square root of n. And if you plug in the values that they give us, so it'd be 50 equals 1.96 times 400 divided by the square root of n.
Oh, gotcha. That's where I messed up. I didn't do the 50 equals 50. That makes sense.
Mhm.
What you end up with?
Rounding to a whole number, it should be about 245.862 and then round up to 246. 246 when you round up.
Okay. Yeah. I believe that's right. That makes sense.
All right.
Yeah.
Okay. Are we ready for question 12?
Yeah.
Okay. So the mean is 100,000, but X is 111,000. Which one do we use?
111.
I think so. But why? Because wouldn't they be
That's
equal?
the equation.
Because in the notes, when you move the equation around, you could do either X minus the z-score times the standard deviation over the square root of n, or you could do the mean plus or minus the same thing.
Okay, so I could try the 111,000 if one of you guys wants to try the other one and see if we get the same.
It'd probably be the 111 just because that's the one that comes with the sample.
Let's make it so-
Yes. Just about. Mm-hmm.
So it's like, well, it's literally an 11,000 difference, obviously.
Yeah.
But
Mm,
I want to say 111,000 would be the right one to use.
I think so too, because that's what we're gonna do is
With the sample.
so for that one I got 99,000
Mhm.
002.
Yes.
And then
122,999. If you round, for rounding, wouldn't you make the 4 a 5? And then the 5 makes the 8.
no, when you do
no,
full
no.
numbers, you just have to look at
Just the very last, the first one?
Yeah.
So it would be 8 because it's okay. Okay, so for question 12, we got 99,002. So 99002. And for question 13, we got 122,998.
Sorry, you're cutting out really bad. What was the first one you said?
So the first one, the lower limit, we got to be 99,002.
Yeah. Okay, I got the same thing.
Okay. And then for the upper limit, we got 122,998.
122 what?
122,998.
Yeah.
Cool. Okay, question 14. There are 3 requirements that need to be checked. They are all of the above. I like how it's gives us the option to choose one or all of them. It's not like check mark each one that's included.
it's like
You're like, really?
you got 100%.
Awesome. Great job, team. Anybody have anything else? Just to meet on Wednesday at 2:15. Does that work for you, Russell?
When? 2:50 Wednesday?
Yeah, 2:15 on Wednesday.
That should be fine.
Okay, cool. We'll see you then.
Cool.